And so the last thing I wanted to mention is that idea of the box, or no, the quartiles, and something called a box and whisker plot. This is very brief. I just want to mention a couple things about it. On the one variable statistics that I showed you a moment ago, we said there was a minimum of 16, a first quartile of 18, a median of 19, a third quartile of 21, and a max of 32. All right, now again, this is found simply by listing out all the data items, right? Literally listing them out in order from lowest to highest. The one in the middle is your median. If you don't have one, if you have two in the middle, then you take their average, which I think in this case we ended up with 2 19s. We've seen this in a previous video. You end up with 2 19s in the middle and you average them and get 19. Then you go from that to the minimum, cut that in half, and you get quartile 1. And then between the median and the max, cut that in half and you get 21. 18, 21, I don't know what I just said. I feel like I said something wrong there. But anyway, you can see what they are. So a box and whisker plot how do you spell whisker? Is that right? I feel like there's an H or something in there somewhere. Maybe there's not. I should look that up, but that's bothering me right now. Is that right? Where are the box and... It is W-H-I-S-K-E-R. Huh, that's weird. Box and whisker plot. Huh. Okay, so a box and whisker plot basically identifies all this stuff. It shows these 5 values. And so if you were to plot out on a number line, all these, the data values here, you have, at some point you have the number 16, that's kind of your minimum. And out here on the right, the max, you have 32. Well, you need to actually fill in some values here. So halfway between 16 and 32 is 24. Halfway between 16 and 24 is what? 20. Halfway here is 28. And then you get 18, 22, 26, 30, and then you can get your odd numbers in here as well, which I can't write in because I don't have room, but there's your scale from 16 to 32. So my minimum is 16. I'm going to put a dot above the line there at 16. My max is at 32. I'm going to put a dot right above the line at 32. My median is at 19. I'm going to put a dot there. Okay, there's my median. My Q1 is at 18. Put a dot there. And my Q3 is at 21. I'll put a dot there. Okay. And so what the box and whisker does, so I have my 5 points plotted. Okay. Basically, you have a quarter of all the data items between each of these dots. All right. In fact, exactly a quarter. If you could take a quarter of 18, I guess. Some of these fall in between, so it's off a little bit. But so what we do then for a box and whisker is we plot a box around the inner 2 quartiles. Kind of looks like a rectangle. It is a rectangle. What am I talking about? There's our inner 2. That's the box. And the whiskers are just a line that extends out from that box over to the max and the min. Okay. We also will put usually a dashed line in here at the median to kind of specify where that is. And so this is just gives you a visual of another way to visualize the data, you can see where all the 50% of the data essentially is clumped in this box, and the other 50%, well, 25% of it is over on this side, and the other 25% of it is over here on this side. Okay, so that's the idea of a quartile. So I'm going to call these, I should probably write that down so you have it. Quartile. And then finally, there's one other topic in here called a percentile. It's similar to a quartile, except it's, instead of splitting it up into quarters, it splits it up into hundredths. So you'd have 100 divisions of this 18 data, which really doesn't work too well, but it does actually. It's doable. Percentile. A percentile basically tells you what percent of the data falls below the item that you're looking at. So if I wanted to, so the median, for instance, the number 19 is at the 50th percentile. What that means is that 50% of all the other data items fall below that number, okay? And if I took a number, let's see, the number 21 is at the 75th percentile, because 3/4 of the data items fall below that number 21, okay? And actually every number on here has a percentile. All you need to do, so say the number 20, if you were looking for the percentile for 20, you just take the number of data items that fall before 20, which would be, let's see, that one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 items that fall before 20, and there are 18 items total. And if you divide 11 by 18, you'll get a decimal that you can change into a percent, and that's your percentile essentially. So this calculation might be a little bit rough. It ends up being 0.611 times 100 gives me 61%. So you're in about the 61st percentile, approximately 61%. So the number 20 is in the 61st percentile. Okay, again, it just means that 61% of the data items fall less than that number. Okay. So anyway, just to give you an idea, there's lots of different measures within the idea of the normal distribution. You got your box and whiskers, your z-scores, your quartiles and percentiles. All these things are valuable, just ways of helping you to understand and perceive, sometimes visualize the spread of the data, the central tendency of the data, and really get all of that together in one nice picture. Okay, so in one nice picture, it could be an actual visual, or it could be numerical values. Whatever the case is, a description of that information.